Right, the last part of this P3 topic then is looking at gravitational potential energy and how this converts into kinetic energy. So when you lift up a book, for instance, and you place it on a shelf, you are doing work on the book. The book gains gravitational potential energy, or GPE, as it is lifted away from the ground. The gravitational potential energy of an object is the energy it has because of its position in a gravitational field. Like the one around the Earth, this energy depends on the mass of the object, its height above the ground, and the strength of the gravitational field. Another example is if you went and stood at the top of a slide, because you've actually gone against gravity and you've put some distance between yourself and the Earth, you now have gravitational potential energy to actually slide down the slide and convert that into kinetic energy. Another example, if you filled up a bucket of water and put it on the top of a door ready to fall on somebody's head, then again that's gravitational potential energy. It's against gravity and it has the potential to transfer the energy into kinetic energy. So if you looked at the calculation for that, which you can see at the bottom of this slide, gravitational potential energy equals the mass times the gravitational field strength, and you should know that on Earth it's 10 newtons per kilogram if we're talking about anything to do with on the Earth. So that's one newton per 100 grams. Times the change in height, so however high you put something. So for instance, if you were looking at the slide example, if you had a 70 kilogram person, so the mass is 70 times the gravitational field strength, which would be 10, times however high they climbed up to get to the top of the slide, and let's just say that was, I don't know, 3 meters. You could multiply those together and you could work out the gravitational potential energy of that person. Now this is actually used to calculate roller coasters and look at where, like for instance, the drops can be and how high the drops have to be, and where they need to gather more gravitational potential energy in order to get the kinetic energy for the movement of the car. So we need to have a look at how this works in terms of roller coasters. So a ride on a roller coaster is exciting because it is designed to provide large changes in kinetic energy. The changes in speed provide the thrilling ride. All roller coasters convert gravitational potential energy into kinetic energy, and the track has some large drops. When the roller coaster cars move from these drops, their gravitational potential energy is converted into kinetic energy. Bigger drops cause a larger change in gravitational potential energy, and they provide a greater increase in kinetic energy, which is what people want, you know, because it's all about the thrill of the ride. The opposite happens when the cars go up the slopes. Here, the kinetic energy of the cars is converted back to the gravitational potential energy as they climb higher above the ground. So you need to make sure you've got enough mass in the first place in order to push it over the top. And this does happen sometimes at Alton Towers. I think it's is it Oblivion? Is it where it just falls down into the hole? Sometimes they don't have enough mass in the actual car itself to push it over the edge so that it'll have the kinetic energy, and so that causes big problems. There are a couple of factors you need to remember, and I'm really going to stress this because if this comes up in an exam, it's usually worth 2 or 3 marks, and even if you don't understand it, the point is if you just wrote this exact term, it would get you the full marks. If you doubled the mass, you will double the kinetic energy. Okay, so double the mass, double the kinetic energy. If you doubled the speed, you would increase the kinetic energy by 4 times. It would quadruple. So please try to learn those two terms. Double the mass, double the kinetic energy, double the speed, increase the kinetic energy by 4 times. Now these are some calculations that you may need to know. These will be given you at the front of the exam paper for you to use, but don't worry too much. Just make sure you understand how to work out gravitational potential energy, which, like I said, is the mass times the gravitational field strength times the change in height, and kinetic energy. Okay, so as I said there, if the mass is doubled, the kinetic energy doubles. If the speed is doubled, the kinetic energy quadruples, and that's really important to learn that.